Hello, everybody, and welcome to the lab off hours where I forgot to hit the record button again. Oh boy. So, just to catch everybody up on where we are and kind of the context for this video. So earlier today we were looking at the a POC on how to basically put data on screen. So this is for things like the last subscriber, the last bits donation, so on and so forth, and how we are basically able to put that data onto the OBS screen. And in that process, we kind of came up with this idea of a metric store, where when we receive a subscriber even, when we receive a bits donation, so on and so forth, we have to capture that data somewhere. And somewhere around the end of that stream, we were thinking about using the ledger for that purpose. The problem with the ledger is that the ledger was very much hard-coded to the idea of the greeter. So the idea that the key was the username and then the value was the timestamp that user was greeted. So not really reusable. So where I started to go down was this path of generifying the ledger such that it would be more like a generic key value store than it would be very specific to the greeter. And so, unfortunately, because I failed to actually hit the record button, nope, I have Vim and Ledger. So let's start from the top. First and foremost, Ledger now has 3 different functions. So get is a new function. This get function, given a key, will return a string value or an error. I'm using string here and effectively enforcing the stringly typed Ledger interface. I might change that in the future, but for right now, a stringly typed value is more or less perfectly fine for what I need. The add function has been renamed to put, and put is kind of more of the convention for key value pair type stores. Think Redis and so on. They typically use put as a moniker for add a value to the store. And then we still kept absent because the idea of absent still being a like get and then check if that value was not null is still valuable, especially considering that get returns a string or an error. And to represent absent, we would basically have to do get key if error equals nil, then that value is absent, and that kind of convolutes the code a little bit. Now, in changing that interface, we basically had to start going down a very long path of wondering why this floating interface continues to fail me. Oh my goodness. Quit that out, Vim, and let's go into File. File was probably the biggest change in terms of number of changes that we had to make to the existing code, because File was very much it was very hard coded to this idea of, again, username is the key and then timestamp is the value. So what I've done up to this point is I've changed the cache to a map of string entry. And for entry is just key, value, and timestamp. Yes, key is technically a little bit redundant. We'll talk about that here in just a second. And then we have a couple of things like, okay, well, now I'm changing the definition of the line that's going to be written to the file. So I wanted to add some constants to represent that. So entry line size represents that we should expect that a line when written to the file is of the type key, separator, value, separator, created timestamp. And then the indices should be in that order: key, value, and timestamp. And what that more or less looks like, so line separator and field separator are still the same, except a field separator I changed from comma to a pipe. I might change that definition a little bit later to something that's more like a non-printable character. But for now, pipe works more or less perfectly fine for my use case. And then, let's see here. And then I had to add additional logic into what is effectively the hydration logic for the new file ledger. So now we are grabbing token, or we're grabbing key, we're grabbing value, and this is where we're using those new constants. We're still doing the same thing for that. And then here we're now, instead of cache key equals timestamp, which was previously an int64, now it's an entry struct, which has all these values. And again, key is technically duplicated because of the cache, but that's more for convenience than anything else. Let's see here. Flush is kind of the same. L.line, which is basically our function to define how we take an entry and write that out into the file. That has been updated for this new entry struct. And this is now also a string builder, since we have key line separator, entry.value line separator, and then the timestamp as a string. It kind of got a little gnarly as to how this was being represented in a fmt.sprintf. So I decided instead to use a string builder, which to me reads a little bit nicer. Let's see here. So now we have, we do want to change this is kind of where I left off. We do want to change the order here to more represent the interface. So we have absent, get, and now this is put instead of add. Same idea, but just changing the moniker to be a little bit more consistent with typical key value stores. And then the only other things that we really did was we were changing some logic around, okay, well now the entry is, or the value is no longer a flat format, it's now a struct, so we have to do entry.value. So that's for the get function. For the put function, we now have to construct an entry. We have to do a bit of a change for that. And then I did go ahead and add an additional error case, which I realized was not present previously. Before, we were doing ledger.write and then ignoring if there was an error. So I added some error logic. Really, the logic is just wrap the existing error and then send that off to the consumer. But you're going to get the idea. And then flush cache, basically the same thing. We just changed that to an entry instead of to a flat value. And that's pretty much it. So with that being said, though, now there are an absolute ton of things that we need to fix. And one of the things that I'm very tempted to fix is to not use this greeter interface. I'm really tempted to just use the bloody ledger. It just doesn't make a whole lot of sense to have greeter anymore. A greet handler, instead of having a greeter, just use the bloody ledger. So we're actually going to do that. Ledger is a ledger. And then this is going to be if ledger.absent. Do that. Otherwise, ledger.put username. Easy peasy lemon squeezy. Delete that. Ledger is a ledger.ledger. So we're going to need to import that. And then is there anything else? Yes, because put is now... True. Value is technically empty, so we'll just put an empty string. We don't really have to record anything. I don't think. Yeah, we shouldn't have to change that for anything. And now all of these, this is going from add to put G. And all of these so we don't need that. We don't need that. We just need this to be ledger. And that should be good. There we go. Greeter imported but not used. Time not used. And now the only thing left to do is to update the Redis ledger. So this was the last thing that I was on the path to doing. I just haven't done it yet. I do want to rename this to key expiration seconds. That was a change from the simplified config that I didn't use. So now this is same thing. This is no longer add. This actually is put key value that more or less looks like that. Put a value to the Redis store. Check if the given key exists in the store. And now technically the Redis ledger versus the file ledger is divergent right now because we are not... Well, actually, no. It is technically the same because absent, I don't have to explicitly check for the expiration time because Redis is doing that expiration for me. So absent is literally just, does this key exist? Redis will kind of deal with the making sure that if that key is expired, it won't return. So this becomes Redis ledger. And then we need a get key string. This will return a string or an error. Now, the nice thing about the Redis ledger is that because I'm just putting the value, I don't really have to do anything there. Get key, and actually this is just get key, if I remember correctly. If error equals l.pool.do, call get, otherwise return cmd dot Now, actually, this is the part that that I do not recall. Bring this up here. Golang, radix. Is it radix? Yeah. Get. Forget what the get looks like. No? Okay. Full featured Redis client. Let's go to the reference. Ah, there we go. Okay. So here we have to do a var result is a string. Nope. And then here do has an, oh, it's a radix.cmd. Yeah, okay. So it's radix.cmd, destination get foo, okay. Dot .cmd Here is result. And then otherwise this should be result nil. Get the value at the specified key if it exists. Let's double check. Okay. So in a nutshell, what that kind of gives us is a generic ledger that is more akin to, or it is more aligned to this idea of a generic key value store. Now, what this gives us is the ability to use this inside of the metrics interface, which we don't have right now, but it will allow us to create that metrics interface, which we can then start to use for the new HTTP server, which I believe is subs handler. Yeah. So inside of subs handler, we're going to need this. We're going to need a ledger to be passed to the sub handler, and then we can use that as a persistent data store for who was the last sub, who was the last bits donation, yada yada yada. And we kind of have to connect the dots between those, but this is the first step towards getting that working. But that's pretty much it. It was a relatively small change. I did kind of miss, throwing in like, hey, this is what I've done and so forth. Oh, sorry. Actually, before we finish, the last thing that I wanted to look at was the use of in-memory ledger, which right now nobody uses the in-memory ledger. And what I was considering was, because the functionality, there's basically the exact same functionality of the in-memory ledger inside of the file ledger. The only difference between the in-memory ledger and the file ledger is the write out to the file. So the thought was there a way that I could basically take file ledger and rewrite it to be a little more transparent about the use of a file? So the thought there would be that instead of a file ledger, I would potentially call this persistent ledger or persistable ledger, something to that effect. And then the ledger would be the in-memory map, and then a persistence target would be an optional IO read-write closer. Now, the caveat, I think, to that is that I have to figure out whether or not I'm using... I think this is just in flush cache, and in flush cache, truncate... right. So I think this was one of the things that that I wasn't really able to do with an IO read-write closer. Yeah. I don't think I was able to do anything with that with a read-write closer. So for flush cache, what I basically needed was the ability to not only write values and read values from the cache, or from the actual file itself, but I also needed the ability to effectively clear the ledger, the file, and then rewrite the values of the cache into that file, which is fine. I think that it's fine to assume that for a persistable ledger, that this is still an OS file. I may just have to rework that to keep the truncate logic. And I don't think Golang has an interface. Golang IO truncate. Truncate IO reader, perhaps? Hmm. I don't think there's a truncator, if that makes any sense. Codef. No. There's a read-write seeker, read-write closer. Unless seeker, the IO read-write seeker has something. Reader, writer, seeker. Seeker is a C. No. No, that doesn't really give me what I want. So what I was originally thinking was, is there a way for me to... I could pass that in as a truncator, a truncate function, if you will. What I was originally thinking about was, I would love for this, for instead of it to be an IO, an os.file, I would love for this to be an IO read-write closer or read-writer or something like that. Something that would allow me to basically abstract away the idea of if it's a file or if it's something else. And then that way, what I could do is I could add a flag in here that says persist. And if persist is set to true, then for all of these operations, hydrate would technically only run if it was a persistent cache. And then flush to cache would either be a no op in the case of there is no flush operation, or it would be it would basically be this logic, and this logic is generic as long as it's an IO read-write closer. It's this part that's not immediately clear. So I would have to pass that in, if you will, as a truncator, a truncate func, which would be something like a truncate func is a func that takes an IO dot read-write closer and probably returns an error, and then the consumer, the person that is implementing this file ledger or this persistent ledger, would then have to provide what makes sense for your IO read-write closer. So in the case of a file, you would pass in the OS truncate or the file.truncate. For the case of literally anything else, whatever the implementation makes sense, you would have to adjust accordingly. And that would give us a truly generic persistent ledger that could operate in more or less the same capacity as it could be a file ledger, it could be an in-memory ledger, it could be a network-based ledger, a database ledger, it could be whatever bloody ledger you bloody well wanted it to be perfectly honest. We would just have to rewrite this code a little bit. So that's kind of where my head was at in terms of thinking about how to make this a little more generic. I just didn't quite get to that part. I was basically looking at in-memory ledger, recognizing that I was either going to have to re-implement the logic that I added in file ledger for expiring keys. I would have to do that into in-memory ledger, or I could just delete in-memory ledger and make the persistence side of the persistent ledger no op. And then at that point, it's the same thing. It still has the cache. It just doesn't write that cache anywhere, if that makes any sense. But I think that's probably a video for another time, after I spent all that time explaining what my thought process was. But I'm going to get this code committed, checked in, and we're going to do a pull request and then put that into the Discord. So thank you all so much for watching. I appreciate you being here for another episode of the Lab Off Hours. Stay curious, and we'll see you in the next one. Take care, everybody.